All right, part two of the homework help series. Potassium hydroxide is kind of the same as the barium chlorate one. Strontium bromide. Okay, this is the first one that we see the IDE suffix. If you see IDE, that's a pretty good indicator that you're working with a monatomic ion. There are some exceptions to that. Really, what IDE means is that it's an anionic species. So hydroxide, for example, isn't on the periodic table. That's something that you're going to just have to get familiar with, unfortunately. But for most of the homework problems, IDE means that it's an anion and usually going to be a binary ionic compound. So I'm going to take a look at my periodic table and I'm going to try and search for these two elements. I find strontium right here in the second group. That means it's going to be a +2 charge. And I'm also looking for bromide. Bromide over here is in the halogen group, and that's going to have a -1 charge. Head over to my drawing here, and we're going to say we have SR, and it was a 2 plus, and then we had a BR minus. You don't have to write the 1 with the minus. Ones are typically implied in chemical nomenclature. I'm going to do that swapping rule we saw in the last video, and that's going to help me really quickly figure out my charge here. We have now strontium with just one of those, and then Br, and it's going to have a subscript of 2. Now, you don't necessarily need to do the swap for every one of these. Some of you are going to be able to look at this and very quickly say, oh yeah, there's 2 positives, 1 negative. That means I need 2 negatives to balance it. I don't grade your work on this type of question, and so you can just come up with the name if you want. No hard feelings if you do that. But it's a useful trick, and even I find myself doing it sometimes. So, to enter this name, we're going to go capital S, little r, capital B, little r, and then because there were 2 of those bromines, we hit it with an _2. Now, iron phosphate is a really mean one. The reason is because we've got 2 different complicated rules going on. I'm noticing that we have a Roman numeral 2 there, and that's indicating that we have a transition metal that has variable charges. The transition metals have a complicated structure of their electron cloud, and that allows them to make a variety of different ionic compounds that are all stable. And so because they make so many different ions, it's necessary for us to say exactly which ions we are talking about. And so iron 2, we'll deal with that in a second, and then phosphate. I'm also noticing it has that ATE suffix. That suffix tells me we have a polyatomic ion. So I'm going to head over to my polyatomic ion reference, and I'm going to look for phosphate. And here we have it, phosphate. It is PO little 4 and then a superscript -3 there. That superscript tells us what the charge of this compound is. So I've got the iron 2. Oops, sorry. A little drawing glitch there. For the iron 2, we know the charge is just what it tells us it is, 2. So it's going to be a 2 plus. Metals will pretty much always make positive charges. There are some rare exceptions to this in the world, but this is not a class about rare exceptions. It's general chemistry, and so it's a pretty good rule of thumb for us. The phosphate we found on our reference sheet was PO4 3 minus. I think this is somewhere that the swapping trick really does help us out. We're going to swap the 2, take it down there. We're going to take the 3 minus, throw it down there, and this is going to give us Fe 3 PO4 2. Now that doesn't look quite right, does it? It's necessary to use the parentheses with polyatomic ions so that your reader isn't going to look at this and say PO42. Not possible, thankfully. So we're going to go ahead and drop some parentheses in there, and that makes it a lot more readable. This tells us that there are 3 irons and then 2 of those phosphate polyatomic ions. When I go ahead and write this in, we're going to be really careful about our syntax here. So it is Fe underscore 3 open parentheses PO underscore 4 close parentheses underscore 2. And so that's telling us that we have 3 of the irons and 2 of the phosphates, and a phosphate is a PO4. Carbon monoxide. Anytime you see the Greek prefixes, things like mono, di, tri, tetra, these are always going to be for covalent compounds. Covalent compounds, which you probably saw in your reading, are things made from just this top right corner of the periodic table. These are the nonmetals, and nonmetals behave differently than metals. And so because they behave so differently, we give them their own set of rules for nomenclature. Carbon. We're going to find carbon, or actually, sorry. It's a little bit more complicated when you're going from the formula to the name, but going from the name to the formula is pretty straightforward. All you have to do is write down the elemental symbol and how many of them there are. Notice that carbon doesn't contain a mono in front of it, and that's because for the first element, it's assumed that there is one unless something else is written. So this is just a C. Don't include the subscript 1. For the monoxide, mon tells us there's going to be one of them, and then oxide tells us that we have oxygen. And so, because it's just one of them, it's just a capital O. Okay, let's try another one like that one. Let's do a diboron tetrafluoride. So, diboron, that tells me that we are going to have a covalent compound because we have the Greek prefixes. Di means 2, tetra means 4. And so I'm going to have B underscore 2. Boron from our periodic table is this guy right here. It's just going to be a little bit of scavenger hunting when you guys are doing these, but before too long, I think you'll become familiar with what the element names and symbols are. Then fluoride is this guy right here. Note that we changed the suffix for the second element. That's just chemical convention, that the INE is going to become IDE. Please note that fluorine is chemical F, not FL. FL was added very recently, fluorovium. It is incredibly radioactive. It's never been observed with the naked eye, and you most certainly are not going to be dealing with it in this class. And so even though FL seems like it should go for fluorine, it does not. Please make sure you consult your reference when you're doing these types of problems. Let's do this one. So I don't think that we've done an example of a binary acid yet. Binary acids are always going to start with hydro. Because they're acids, we know they also start with the letter H. And because they're binary, that means 2 things. And so if one of them is H, we should be able to figure out what the other is pretty easily. So just looking at the root word there, I see chlor, like chlorine. Taking a look at my periodic table, I see chlorine right here in this second to last group of the periodic table. It's important when you're doing the acids to figure out what their charges are first so that you can make sure you have a balanced chemical formula. That means going back over to our drawing here, and we have H, which is a +1 because it's in the first column of our periodic table. We have chlorine, which we just found out was in the second to last group, making it a -1. And then we're going to do the swap. Now, many of you probably wouldn't need to actually draw all of this out, and that's just fine. We can see this is now HCl, and that's the full name. So to draw this, or to type it rather, just HC and make sure you put a little L there, and there you have it. All right. I think that covers all of the major types of problems you're going to see from this particular assignment. Um, hopefully this video was helpful to you, and I'll do at least one or two more of these for the molecular names assignment. Until the next time.